Imagine a single elegant theory. This theory would explain everything in the universe. From the smallest particles to the largest galaxies, it would reveal the secrets of how everything works. This is the dream of the theory of everything, or TOE. It's a theory that unites all the forces and particles in the cosmos. It's a theory that explains the very fabric of reality. For centuries, physicists have been on a quest. Their goal is to find this ultimate theory. They want to understand the universe at its deepest level. The TOE is the holy grail of physics. It represents the pinnacle of our understanding of the natural world. The search for a TOE is a journey into the unknown. It's a journey that takes us to the edge of our understanding. But it's a journey worth taking, because if we succeed, we will have unlocked the secrets of the universe. We will have glimpsed the mind of God. The quest for a unified theory of the universe is not new. It has been a driving force in physics for centuries. From the ancient Greeks to Isaac Newton, thinkers have sought to find common principles underlying the apparent complexity of the natural world. Isaac Newton gave us a major breakthrough. His law of universal gravitation showed that the same force governs the fall of an apple and the motion of planets. This was a profound insight, uniting heaven and earth under a single law. Then came James Clerk Maxwell, who unified electricity and magnetism. His equations showed that these two seemingly different forces were actually two sides of the same coin. This paved the way for our understanding of light as an electromagnetic wave. These successes fueled the dream of a final unification, a theory that would explain all forces and particles in a single framework. This is the ultimate goal of the TOE. In the 20th century, physics underwent a revolution. Two groundbreaking theories emerged: Einstein's theory of general relativity and quantum mechanics. General relativity describes the universe on the largest scales. It explains the behavior of stars, galaxies, and the universe itself. Quantum mechanics, on the other hand, governs the microscopic world. It describes the bizarre behavior of atoms and subatomic particles. Here's the problem. These two pillars of modern physics seem incompatible. General relativity describes gravity as a smooth, continuous curvature of space-time. Quantum mechanics describes the universe as fundamentally granular and probabilistic. This clash of titans has been a major obstacle in the quest for a TOE. The challenge is immense. We need a theory that can bridge the gap between the very big and the very small. A theory that can describe gravity in a way that is consistent with the principles of quantum mechanics. Section 4: Strings, Loops, and Hidden Dimensions. Despite the challenges, physicists have made remarkable progress. Several promising candidate theories for a theory of everything have emerged. Two of the most prominent are string theory and loop quantum gravity. String theory suggests that the fundamental building blocks of the universe are not point-like particles but tiny vibrating strings. Just like a violin string can produce different notes, these strings can vibrate in different ways, giving rise to all the particles and forces we observe. It's a beautiful and elegant idea, but it requires the existence of extra-spatial dimensions beyond the three we experience. Loop quantum gravity takes a different approach. It proposes that space-time itself is quantized. It's not smooth and continuous, but made up of tiny, indivisible chunks. Like pixels on a screen, these chunks of space-time create the fabric of reality at the smallest scales. This theory has the potential to unify gravity and quantum mechanics without the need for extra dimensions. Both string theory and loop quantum gravity are still under development. They are highly complex and mathematically demanding, and they have yet to make testable predictions. But they represent our best hope of finding a theory of everything and unlocking the secrets of the universe. Section 5: The Undiscovered Country, Unraveling the Mysteries of M-Theory. In the late 20th century, a new contender emerged on the scene: M-theory. This theory attempts to unify the different versions of string theory into a single framework. It's a mind-boggling concept, involving 11 dimensions and objects called branes, which are surfaces that can exist in higher dimensions. M-theory is still in its infancy. We are only beginning to scratch the surface of its implications, but it has the potential to be the most comprehensive and profound theory ever devised. Imagine a theory that could explain the origin of the universe, the nature of dark matter and dark energy, and the ultimate fate of everything. The quest to understand M-theory is a journey into the unknown. It's a journey that will require new ways of thinking and new mathematical tools. but it's a journey that could lead us to a new understanding of the universe and our place within it. Section 6. Echoes of the Big Bang. The Big Bang Theory describes the origin of the universe as a hot, dense state about 13.8 billion years ago. But what caused the Big Bang? What happened in the very first moments of the universe's existence? These are questions that current physics cannot answer. This is where a theory of everything could shed light. It could provide a description of the universe that is valid, even at the extreme temperatures and densities of the Big Bang. By unifying gravity and quantum mechanics, a theory of everything could help us understand the quantum fluctuations that may have seeded the structure of the universe we see today. Imagine unraveling the mysteries of the Big Bang. Imagine tracing the evolution of the universe from a tiny speck of energy to the vast cosmic web of galaxies we see today. This is the promise of a theory of everything, to illuminate the darkest corners of the cosmos and reveal the secrets of our cosmic origins.